Okay, so writing the first one in scientific notation. So before we do the sig fig part, let's just do this in scientific notation. So remember you put a dot after the first digit.
It's going to be times 10 to the 6, isn't it?
Yeah. And then we write all the significant figures and then we time it to the power of 10 to the power of 6. But they want two significant figures, so we're going to cap it. So we're going to cap this part. So how would we round that to two significant figures? Is it 3.4? And don't forget the times 10 to the power of 6. That still remains, it's only this part that we're rounding off. So that's 1 mark. Okay, so the next one is find k, the equation has no real roots. So when you see the word roots or real roots, equal roots or any roots, it's all about discriminates. So do you remember the discriminant rule? No.
Oh wait, is it the same one as
It's the inside of the quadratic equation.
axis of?
No. It looks very similar, but it's not.
Okay.
It's the inside. It's the inside part of the quadratic equation. So inside bit. Okay, so we're just gonna substitute. So b in this case is what? Number or letter? K, negative k.
Yep.
So if it helps, before you begin, you write down what your coefficients are. A is 1, B is negative k, and C is 4. So negative k all squared minus 4 times 1 times 4. So that gives you, I'm just expanding it for now before I start solving it. So this is the expansion. So the first bit is to find the coefficient. That's our first bit here. First bit, find the coefficient. Second bit is to substitute into the discriminant rule. Now the third bit is, they say that they want no real roots. So we only have 3 conditions. Remember your 3 conditions? No real roots is when the discriminant is less than 0. Is it? Yeah, that's no real roots. Equal to 0 means that it's either 1 root or equal roots or double roots.
And then greater than is all real, isn't it?
Yeah. Greater than is all, 2 real roots or 2 roots. And then there's extra conditions like if it's a perfect square, then you have rational roots, but we'll go into that in other questions. But for this one, we're only concerned with those 3 conditions. So in this condition, we want no real roots. So we take, so that's what our discriminant is. So we want our discriminant to be less than 0. So what we have here is we have a inequality though. So we've created an inequality. And remember when we have inequalities, we've got to test our solutions. So we're running out of space, but we factorize this. And our solutions are 4 and negative 4. But you have to test your solutions because it's an inequality. So we're going to just test. So we'll test a number between negative 4 and 4, which is 0. So substituting 0 into this is 0 squared minus 16. Is it less than 0? Yes. So that works. And that means the solutions lie between negative 4 and 4. So how would you express this algebraically?
Negative 4.
Yeah?
That weird symbol, 0, and
Yeah.
that symbol.
Oh, no zeros.
So you put
I'm running out of space, but that's our final solution there. So well, how you would express this as x is in between, x is greater than negative 4 and less than 4. In between is pretty much just in between these 2 symbols. So the solution lies between these 2 points, and to express it algebraically, we put it between these 2 inequality symbols.
So when you test it, you can choose any number.
Yeah, you can choose any number. We always choose 0 because 0 is pretty easy to work with. 0, 1s are easy. Say if this condition doesn't hold, say it doesn't hold here, Then you'll have to test this, the conditions here and here. Your only two options are it's either inside, it's either between, or on the outside. So in this case it's inside, so we write it like that. Question 3 is we've got a function. So fx equals 3x cubed minus 3x squared. Find the stationary points and then determine their nature. So before we begin, this cubic should give us a hint. So how many stationary points do you reckon? 2? So we have 2 stationary points.
It's going to be
How?
point of inflection or something.
Yeah, 1 point of inflection. So that should give you a hint to start. Okay, so your solutions is your stationary points. Every time you see the word stationary points, you have to find the derivative. So f dash x is what?
3x squared minus 6x.
3x squared minus 6x. Then, because we're looking for stationary points, what's our next line working out? Stationary points occur when the derivative is equal to 0. So we substitute 0. And then the next step, after substituting fx equals 0, what's the next step after that? Solve?
Yeah.
Solve from
Sorry.
Should be.
Alright, so we solve for it by factorising or solving the quadratic equation. You can see that this one's actually easier to factorise, so I just factorised. So we're solving for x, so therefore
X equals 0 and 2.
x equals 0 and 2. This gives us the coordinates to the stationary points. So because we only had the x coordinates, we have to go back and find the y coordinates. So let's start with when x equals 0. So when x equals 0, y equals, where do we substitute into?
Original.
Yeah, the original. So we just substitute to that. So 0 cubed minus 3 times 0 squared is just 0. So our first one is 0, 0. Let's find our second. So we've accounted for x equals 0, and let's account for x equals 2. So when x equals 2, y equals 2 cubed minus 3 times 2 squared. So that's 8 minus 12, which gives you negative 4. So you have 2, negative 4. So remember, always substitute back into the original. You know you've done it wrong is when you substitute it into your derivative. Into your derivative and you get zeros. Okay, so that's just stationary points. Now we need to determine their nature. So we've got 2 stationary points. Okay, so it's up to you. First, you can do it 2 ways. You want to do it first derivative way or second derivative way?
I like second derivative.
You like second derivative way? So second derivative means we have to derive it twice. Which means that's, what's the second derivative of that?
6x minus 6.
6x minus 6. And what do we do with the second derivative? Huh?
Who knows?
What do we do with the second derivative? Do you remember?
No.
No. Okay, well we substitute. So when x equals 0, let's see what it gives us when we substitute it. And minus 6 is greater or less than 0. And remember what I said with that negative?
Is that concave?
It's negative, so it's sad face. Yeah, concave down. So concave down gives you what type of stationary point though? It gives you, what's that point?
Max.
Max. When they say determined its nature, we're talking about whether it's max or min.
Does that mean the other one's going to be min? So it's going to
Yeah,
be greater
well-
than 0?
Well, yes, that's what we're looking for. The other one is going to be min, but we need to prove it. So once again, our second derivative is this bit. So we're going to substitute 2. So when x equals 2, our second derivative is going to be 6 times 2, which is 12, which is positive 6, which is greater than 0, concave up. Just don't get confused between, your concavity and your min-max. Concave up, so min. Alright, so that's just the two stationary points. What about our point of inflection? Running out of space, but point of inflection. How would we, yeah, so we make the second derivative equal to 0. So this is our equation for our second derivative. We make it equal to 0, and we solve for x. What would x be equal to? 6x equals 6. X equals 1. And remember, this is just the x coordinate, so what happens for...
You have to sub that back into that.
Yeah, so we want to find the set of coordinates. So when x equals 0, or when x equals 1, y equals...
What equation do you sub it back into?
Always the original if you're finding coordinates.
Okay.
So these are coordinates. If you're determining nature, then you substitute it into the derivatives. But the minute you found their nature and you're going back to find their coordinates, you substitute into the original. So this would be okay, well our original equation is
It's going to be
yeah. So it's at 1? Are you sure? Yeah, negative 2. So it's going to be 1 to the power of 3 minus 3 times 1 squared, which is just 1 minus 3, negative 2. So your coordinates are going to be 1, negative 2. That's your point of inflection. Okay, point of inflection. Right.
sketch.
Okay, now we just have to sketch it. So when you sketch, what do I have no space for? So I have to sketch it here. When you're sketching this, you already have your you already have your stationary point, and you already have your point of inflection.
Yeah.
But you don't have x and y intercepts. So you're going to let's find your y-intercept first because it's the easiest one. So when we find y-intercept, what do we substitute?
X equals 0.
Yeah. Y-intercept occurs when x equals 0.
So y equals 0.
Yeah, so substituting this in, 0 cubed minus 3 times 0. Yeah, it is 0. So remember, it's always the original when we're looking for coordinates.
Isn't that like what we...
We don't really read coordinates down there.
0,
Yeah.
2, and...
What we've done here, these are the coordinates of your
turning point.
turning points.
Okay.
So this one was max, and this one was min. So what we're looking for here, and this is point of inflection.
Yeah.
So what we're looking for here is just the y-intercept now. So where it cuts the graph, and now the x-intercept. This one's a bit, this one you can actually find because it's easy to factorize. So what do we have? We have x cubed minus 3x squared.
Isn't that just the 0 and the...
Yeah, well what's common? What's common?
very high x?
X squared.
Yeah.
And then we have x on the inside minus 3 on the other side. So that means x
0
equals...
is 3.
Okay, so what this would look like? This is the x-intercept. It's the y-intercept. So what the graph would look like is cuts it at 0, cuts it at 3. We call this part here a double root. So if it's a double root, it means that the graph sits in the curve like this. And see how this curve, I actually did it wrong. A double root means, when we draw it, a double root means it sits on top of the x or y axis like that. But we have to go back and now determine your stationary point. So we have a max at 0, 0. Is it max? So we have something like this at 0, 0.
Yeah.
And we have a min at 1, negative 2. So that's 1, and that's negative 2. And then we have a point of inflection. No, that's point of
2
inflection.
negative 4.
2, negative 4. So 2, extend it, negative 4. So we have a min here, and then we have a point of inflection at 1, negative 2. So it just tells me that the graph goes from concave down, and it changes directions to concave up. Obviously you're going to do this with a pencil, you're going to try and make it neater than how I've done it. And then the graph comes up and cuts the x-axis at 3, and it comes up and it cuts the x-axis again at 0. This is what the graph looks like. Alright, and now question 4 is to find the primitive. So this one you can do easily. What's this? Primitive is the opposite of derivative, so
You're
what
on
do we
camera,
do?
by the way.
Doesn't matter. What do we do? That'll. Do you mind that your face will come up?
No, I won't see.
Okay.
Yeah,
so
you won't.
what happens to the power? We're changing it. We're not doing the derivative. We're doing the primitive. So what happens to the power?
Did I just sit in?
What happens to the power?
Goes down.
Up. What about the? He still is technically. What about the? What do we divide
Frenchie,
by?
you're on camera.
But it's not here.
Yeah, no, he's down the bottom.
It's really red.
He's,
You get
he's
some.
coming up now, so I don't know how long.
Yeah, I got some of the other faces here. I have
Face,
faces.
forehead.
Okay, so we divided by the new power
Yeah.
minus
Oh,
8. 8 what? Minus 8.
Over 2.
I think we started just now.
8 over 2. 8x. 8x.
Yeah.
Okay, and then because we don't have any other conditions, we plus C. That's it, that's your answer.
Really?
Actually, no, more.
Yeah,
Continue. E12.
Don't come in and disrupt our class.
We. It's really, really,
Don't
really.
shut down fast this afternoon. Deal.
And I'm not cutting this out either, so we just simplify it. Look,
Would we get
I'm
down?
really picky. I am really picky. I don't like it unsimplified, so I would prefer that you simplify it. So that's why you should always simplify your questions. And question 5 is similar to question 2, because I think you need a bit of practice on these questions. So once again, you see the word roots. What's the association? Roots is associated with discriminants. So that means when you look at your quadratic equation,
You cry.
no, you don't cry. You find your coefficients first. Remember that was the first step. So what are the coefficients? It's A, B, and C.
4.
4,
K.
K, 9. Okay, good. Second step,
You sub it into
you substitute it. Yeah.
B minus
So remember, it's the inside part of the surd, so that should help you to remember this. So it's going to be k squared brackets 4 times 4 times 9, which gives you k squared. 16 times 9, 144.
Didn't do it off the top of your head. Yeah.
All good.
Better like than never, Dad.
Just got 2 minutes, man. It's alright.
It's all good. It doesn't matter. I'll turn the camera off in 2 minutes. Just finishing this. It says that we have equal roots. So what's the conditions for equal roots?
That they have to.
Remember, this is our discriminant. The
Equals
discriminant
0.
equals to
sorry.
0. Alright, so that means the discriminant's not the triangle. Well, what you can do is you can replace the triangle with 0, and then you can solve for it. Since this is an equation and not an inequality, you don't need to do the number line. So you just solve for this. What is this? Minus 12 and plus 12. Don't forget, it's a difference between perfect squares. So
Take
therefore
one point
k
on the other side.
equals 12 and negative 12.
Oh, no.
And that's all you need to do.
That's all you need
You
to
don't need
do.
to do all that crap that we did last time.
This, do you mean this one?
Yeah, do you have to do that, that minus 4 is
Girls.
greater than x and all that stuff?
This part here
Yeah.
is testing your solutions.
Yeah,
You test your solutions because it's an inequality.
okay.
It's only when it's not an inequality that you don't test it. So an equation's easier than an inequality. So equal roots are pretty easy to do. Equal roots and stuff, they're equations.
Yeah.
And the other two, which are no real roots and 2 roots, you got to do that extra step of doing the number line and testing your solutions. Okay, are we good?
Yeah.
Bye, bye. Bye.
That's
So
all
that
right.
comes in writing time.
Enjoy the reading.
Okay, we're going to test, guys. Good luck. We'll be testing.